number 8 as well, okay? So the first thing we're asked to do is construct a force diagram, okay? And I'm just gonna read this. So a 3 kilogram object. So immediately I see the 3 kilograms and I'm just gonna figure out what the weight is, okay? Remember, weight is Fg, okay? So Fg is equal to mass times gravity constant. So Fg is equal to 3 times negative 9.8. Okay, so I'm just going to pop that in my calculator. So 3 times negative 9.8. We end up getting 29.4. So Fg is equal to negative 29.4 newtons. Okay, so I just kind of have that. Just kind of have it ready to go. Okay, so the 3 kilogram object is moving along the floor. So that tells me that we have some sort of like a box or something, and it's on a surface. Okay. That also tells me what one of my forces is going to be. Okay, so if it's moving along a surface, that means that I have an Fn. So I'm just going to fill this out kind of as I'm going through the problem. So Fn is equal to positive 29.4 newtons. Fg is equal to negative 29.4 newtons. Okay. Experiencing a positive 11 pull force and a negative 4 newtons friction force. Okay. So this part of the question is asking that you know that if you have a negative force, the only spot left that has negative, it has to be the leftward force. And that means that this positive 11 is going to be pointing right. And again, this is requiring that you remember that negative is always left and down, positive is always up and to the right. So I'm just going to go ahead and fill these out as well. So my 4, I'm going to make small. My 11, I'm going to make longer than the 4, but shorter than the 29. Okay. Again, you want to try to approximate this. It doesn't need to be perfectly like symmetrical or ratio to the others, but they should be approximate. So the object is moving, so that means it's FFK, the kinetic friction force, equal to negative 4 newtons. And my FP is equal to positive 11 newtons. Okay, so if I'm looking at this, I can see, let's switch some colors here. So I can see that this force and this force cancel out, right? Because again, if I add those two together, I would get 0. My left and right forces, though, on the other hand, do not just cancel out. So I'm going to figure out what my F net is by adding those together. So negative 4 plus 11, I end up getting 7 newtons. So 7 newtons is equal to my net force. Okay. All right, so then we're asked, so we made our free body diagram. I solved for Fg. I'm able to figure out my F net already. For B, it's just asking me calculate the acceleration of the object. So for this is where I'm going to be using F net is equal to M times A. Okay. And most of the time when you see this, you do see it just as F is equal to MA, okay? I'm putting the net in just so that we are being very deliberate that this is a different force compared to the other forces on this page, okay? So F net is equal to our mass, which is 3, times our acceleration, which, whoops, actually we know the net force, sorry, which is 7. We do not know our acceleration, okay? How are we going to get A on its own? We need to divide, right? Do we see how if we divide each side by 3, that isolates A? So 7 divided by 3 is equal to 3A divided by 3. And we do the math on this, and I think it's like 2.3. Yeah. So 2.3 meters per second second squared is equal to A. And then that's our answer. Unit for acceleration is always meters per second squared, okay? You can also, if you type it, the correct way is to use that little caret symbol, okay? You can use shift and then click the number 6 on your keyboard to get it. If you're forgetting what that symbol is though, and you just write meters per second 2, we'll also accept that, okay? But it's very important that you include the 2, because if you aren't, then technically that's a velocity unit, okay? So you want to be careful with that. Going down to C, if an object was moving to the right, would it be speeding up or slowing down? Okay, so if we're moving to the right, are we moving with the net force or are we moving against the net force? With the net force. We would be speeding up. So the question in the chat, how did I find the mass? So I found the mass just by, that was something that was given to us up here. Yeah, so I can actually label that too. Which that's also a really useful thing as you're kind of reading through, thank you for pointing that out. It's a really super useful thing to, as you're reading through your problem, to just label every number that you see so that you're trying to process and trying to break it down kind of like as you're reading through it. Yeah. Okay, so then moving on to this next one. So number 8. So 4 kilogram objects, so kilogram, that's mass, is moving along a floor, and I have my box and my my line set up there. One is a rightward pull force. Okay, so this is my FP, and the object accelerates at a rate of 2 meters per second squared. Okay, so I also have my acceleration. What is the friction? So this tells me that there is a leftward force. We just don't know it yet. Okay. All right, so we start off by solving for Fg. And remember, Fg is just equal to mass times gravity constant. So Fg is equal to 4 times negative 9.8. And I'm going to go ahead and plug that in here. Whoops. And we get 39.2 negative. It's equal to negative 39.2 newtons. So I'm going to go ahead and plug that in. It's much larger than my net force of 12, so I'm going to make this arrow my long arrow. Oh gosh, that green is just kind of awful. I'm going to switch back to the purple. Again, I'm trying to make these arrows about the same length. I'm not sure if I'm succeeding exactly, but it, like, just eyeballing it. As I'm typing these in, when I'm typing my forces, whoops, FG, yikes. As I'm typing these in, first of all, I am typing. I'm not using the drawing symbol. I'm actually typing, okay? It's much easier if you type this stuff, y'all. I'm including if it's negative or positive. I'm including what force it is. I'm also including a unit. These are all things that you lose points on quizzes. And then we have the rightward 12 Newton pull force. I'm just making it just a little bit shorter. FP is equal to 12 newtons. And I don't know what my friction force is yet. So it says to calculate the friction force. So let's think about this for a second. So my FG and my FN cancel out. It's moving along the floor and it's accelerating, which tells us that we have non-balanced forces, which tells us we have some net force that is a non-zero number. We just don't know what it is yet. So let's go ahead and solve for net force. Net force is equal to mass times acceleration. So our mass is 4. Our acceleration is 2. So F net is equal to 8 newtons. Okay, so if net force is equal to 8 newtons, here, because I know that this force is some sort of a friction force, the object is moving, so it's an FFK. I just don't know what the magnitude is. But I know that my net force is equal to FFK plus FP. Okay? So I know that my net force is 8 newtons. I don't know what my FFK is yet. I know that my FP is 12 newtons. Do we see how for this problem I would subtract 12 from each side? So 8 newtons minus 12 is equal to FFK plus 12 minus 12. So then we would, I should put an N there. So then we would just have negative 4 newtons is equal to FFK. So FFK is equal to negative 4 newtons. But did we see how we got that? I solved for our net force using my F equals MA. And then I solved for FK, taking advantage of the fact that F net is always equal to the sum of the forces that are opposite each other. Okay, then this bottom question, if the object was moving to the right, would it be slowing down or speeding up? So again, we have to think about if we are moving to the right, are we moving toward the net force or away from the net force? We're moving with the net force, right? Or toward the net force. So we are speeding up. Okay? And I want to point something out. This question has 2 parts to it. So would we be speeding up or slowing down, and how would you know? And actually, here, wait, let me make the how would you know a different color. How would you know? So the how we would know is this. The are we speeding up or slowing down is this. Okay, so a question like this would be worth 2 points, and it'd be worth a point for each of these little parts. So the explanation is a point, and then getting it correct is a point.